Hi, my name is Jesslaine, and this is going to be a video on conditional statements for geometry class. So let's just talk about what a conditional statement is. I kind of want to put my computer over here so I can look this way instead of behind me. So try with me, hopefully it doesn't fall. But a conditional statement is a statement that can be written as an if-then statement. So for example, if you eat breakfast, then you will feel better soon. So that's an if-then statement. If you eat breakfast, then you will feel better soon. If you want to go like geometry-wise, if two angles are supplementary, then their sum is 180 degrees. So that is true. If two angles are supplementary, then their sum is 180 degrees. That conditional statement is actually true. The hypothesis of a conditional statement is the part that comes right after the if. So if two angles are supplementary, so if two angles are supplementary, so this is what you call the hypothesis. So that is the part that comes right after the if. And then their sums are 180 degrees. And so, so in this case, this after the then is what you call the conclusion. So hypothesis and then the conclusion. So let's write a conditional statement. If I was just given vertical angles are congruent, that's not a conditional statement because remember a conditional statement is an if-then statement. So it says vertical angles are congruent. So we could change that to a conditional statement that says if two angles are vertical, then they are congruent. So now we've made a conditional statement because it's an if-then statement. And then we can say that is true. If two angles are vertical, then they are congruent. Not all conditional statements might not be, yeah, so this conditional statement is true. Okay, a counterexample, let's talk about a counterexample would be opposite of the statement to kind of like prove the statement is false. So if two angles are vertical, then they are congruent. Well, we know this is true. There is no counterexample for that. But what if I have a statement that says, if you live in Tennessee, then you live in Nashville. If you live in Tennessee, then you live in Nashville. We can give a counterexample of, let's say, Chattanooga. If somebody lives in Chattanooga, they still live in Tennessee, but they're not in Nashville. So that's a counterexample to that statement. Okay, so let's talk about conditional statements. So the first thing is just, let's just talk about how they're written. So when you see this, P and then an arrow and Q, this means if P, then Q happens. So if P, then Q happens. So you'll see it like this, and this means conditional statement. So P, arrow, Q, that means to write a conditional statement. And so, for example, if P is a number is prime and Q is a number has exactly two divisors, we would write that if a number is prime, so that's your P, so that's your P. If a number is prime, then, which is your Q, then it has exactly two divisors. So right here, that is your Q. Okay, so if P, then Q. So some other symbols that you might see are this symbol, this little squiggly symbol. This means not, the word not. So if you see this, that means not P. So that means you would have to negate what P said. So in this case, P was a number is prime. So to negate that, you say a number is not prime because we want not P. So a number is not prime. Okay, so we've gone over that. Now this symbol, the little rooftop symbol, we use it sometimes for an exponent on the calculator, but in this case in conditional statements, it means and, the word and. Okay, so if I have P and Q, that means that both of those have to be true for my answer. So for an example, if P is a number is even, so P is a number is even, and then Q represents the statement a number is divisible by 3, then when I say I'm looking for this, P and Q, then I have to pick a number that satisfies both statements. So think about it. A number is even, a number is divisible by 3. So the first number there would be 6. 6 is an even number, and it's also divisible by 3. So this satisfies both statements, so that could be an answer to P and Q. 12 could also be an answer. It satisfies both statements. And there's many more answers, okay, that you can do. But when it says P and Q, you have to satisfy both statements. Another symbol that you might see in a conditional statement is the upside down carrot top, a V, and this word means or. Okay, so this word means or. So if I had the same P, so a number is even, I should have left it, huh? A number is even, and Q, a number is divisible by 3. So if I have those statements and I write that I want to find P or Q, that just means I just have to satisfy one of these statements, if P or Q. So I could pick an even number, 2. 2 would be an even number, so it satisfies P, so this is an answer to P or Q. Or I could pick 9, because that satisfies just Q, but not P. But it doesn't matter. It only has to satisfy one of the statements since it's P or Q. And then I'm just going to tell you what this means without erasing it. If you see 3 dots, it means the word therefore. Okay? It means the word therefore. So if you see 3 dots, you can know that it means the word therefore. Now let's talk about conditional statements and 3 ways we can write conditional statements. We can write the converse, we can write the inverse, and we can write the contrapositive of conditional statements. So let's first talk about the converse. Like the shoes. Yep, like the shoes. Converse, okay? So we know what this means. This means if P, then Q. Well, when we're writing the converse just would do this. If Q, then P. So basically you just switch the statement. So let's say we have statements, and our conditional statement was if 2 angles are vertical. I tried to pick something short because I knew I'd have to be writing these. If 2 angles are vertical, then they are congruent. So there's our conditional statement. And we want to write the converse of this conditional statement. So if this is our original one, then this is the converse. So what you do is just flip it. So when we flip it, we say if 2 angles are congruent, you see we flipped it from if 2 angles are congruent, then they are vertical. Okay, then they are vertical. So this is our conditional statement. This is our converse of our conditional statement. Let's see if they're true. The first one, if 2 angles are vertical, then they are congruent. That is a true statement. And then the converse of the conditional statement is if 2 angles are congruent, then they are vertical. Well, I can give a counterexample of that. A counterexample would be I could draw two right angles and they are congruent, but they're not vertical, they're not straight across from each other. So this statement is false. Okay, let's talk about inverse. So the inverse, the original, if P then Q. So the inverse would be that we took the opposite of both statements. So we negate them. We do the opposite of it. So if it doesn't have the word not in it, then we put it in. If it does have the word not in it, then we would take it out. We do the opposite of what the statement says. So in this case, so the inverse, if two angles are vertical, then they are congruent. That was our conditional statement. That's our original conditional statement. So to write the inverse of that, all we do is make it negative, both statements. If two angles are vertical, so we would say if two angles are not vertical, then they are not congruent, because we have to take the opposite of that second part too. And they are not congruent. So this would be the inverse. We know the conditional statement's true. Let's see if this one. If two angles are not vertical, then they are not congruent. Can you give a counterexample? Well, I can, because what if they are corresponding or alternate interior? And if you don't know what those are, I have a video on that. But those are angles that are congruent too, just not vertical angles are congruent. So this is actually a false statement. So that's the inverse. That's how you write the inverse. One more. I'm not gonna erase that original statement because we're gonna use it. So the next one is what you call the contrapositive. So in the converse, we just switched the order. In the inverse, we took the opposite of each. And so in the contrapositive, our original, if P then Q, we switch the order and take the opposite. So it's putting the inverse and the converse together. So the contrapositive of this, we're going to switch the order and negate it. So if two angles are not congruent, because we have to write congruent first because we're switching the order and we're also doing the opposite, then they are not vertical. And the contrapositive this time is actually true. If two angles are not congruent, then they are not vertical, because vertical angles are congruent. So here's the thing. A conditional statement and their contrapositive, if one's true, the other will be true. If the one's false, the other one will be false, okay? So there we go. That is a lesson on conditional statements. Thank you.